Next up, we have Sancheeta. Uh, Sancheeta is going to talk about, the talk theme is Green Tech Beyond Renewable Energy Integration, and she's going to talk about efficient algorithms, how you can increase cloud resource utilization, and around that. So over to you, Sancheeta.
Yeah. Can you guys hear me? Yeah. Okay. Thank you so much. Okay. Great. So I think we will talk about green tech beyond the renewable energy integration. And I think before we go ahead, I want to give you a few disclaimers. So I've been a backend engineer with a background in cloud. I worked at Blinkit for almost 8 years, where every engineer who was a backend engineer was supposed to understand and implement DevOps practices in their own teams. So I'm not somebody from the infrastructure world, but I have a thing or two that I know about like cloud. Also, recently I started running this community called Climate Tech Collective, and that's how I also talked to like Nancy and got to know more about CNCF and the initiatives that they are running. The idea of this community was to think about how sustainability and tech can come and meet together. And one of the topics that I talk about a lot there is green software, right? And before we move ahead, one of the things that you guys should keep in mind that this is a very overview and an introductory session. This is more about breadth so that you can take some time and read about more of these topics later. And I think a few of these topics are also deep dived in the talks that I could see in the more upcoming talks after me, right? A lot of things are also just my opinions, should be applicable to most contexts, but may or may not be relevant because sometimes it's not one size fits all. So if you have something that you don't find relevant, would love to hear more about it. And a lot of things that we're going to do here are very, very obvious, but it's very critical that we get the obvious done. As DevOps engineers, a lot of you who might be DevOps engineers here might feel that this is something that I already know, right? But if you already know it, just please go ahead and implement it. That's the best way to learn new and upcoming stuff. So the first question that I would like to ask people here is, I'm a cloud developer. Why should I care about sustainability? Anybody who would want to like share their thoughts on this? Okay, can you tell? Are you a cloud developer? Okay, anyone who is a cloud developer and would want to share. Otherwise, I remember one person that I met from Rajaji Nagar who I would like to ask. Oh yeah, yeah.
Yeah, I mean, I was just saying. Yeah, I mean, because me being working in the DevOps team, we have this whole track, all the dashboards, just showing everything that how much instances we are using, the workloads and everything.
Yeah.
So I think we have the closest idea of what's happening.
Okay.
And that's why I think we should care.
That's
yeah.
fantastic. So it comes from a lot of intrinsic motivation for her, but climate is no longer about intrinsic motivation. There is, so, yeah, exactly. Yeah. Yeah, absolutely right. So today, climate is no longer just a thing that you're doing out of mere consciousness, right? It's a economic opportunity that a lot of people are realizing, and it's also a threat to the mere existence of the human world, right? So cost, as he mentioned, and second thing that's also happening over time is that a lot of the countries are coming up with a lot of compliance requirements. So while it was voluntary until some time back, today it is no longer voluntary in nature, which means that at one time or other, you will have to learn these skills about how to think about sustainability in your workplace, right? And it's more and more sinking in even in countries like India. A lot of people might not be aware, but top 1,000 companies in India are mandated to produce their documents around what are their emissions like in India today, right? So it is growing at a really, really faster pace. So that's why you should care about it. Now, I think somebody already mentioned that IT sector contributes to about 2% of the global carbon emissions. That's something that a lot of people know, but what they don't know about is that it's almost equivalent to what aviation industry does. And if you're somebody who is present in the climate circles, you know how much flack do people who fly actually get, right? Which means that the contribution is actually enormous. 2% is actually a really, really big number, right? So what can be the solution? One of the things that most of the time people think about is, okay, I'll replace my energy sources from fossil fuels to renewable energy, like solar or wind or nuclear to some extent, right? And problem solved, right? But no, it's not the case. Why? Because multiple researchers show that uh, the kind of capacity and utilization at which the data centers run, that can actually be as low as 12%, right? There was another study by Uptime Institute, and I can imagine that Uptime Institute saying this will be very, very valid, because they say that 30% of the servers worldwide are actually unused, right? Which leads to a very big number, which is $30 billion, which is being wasted in terms of energy, right? Now imagine if this $30 billion can be utilized somewhere else. Today, if you go and look, a lot of countries in the world don't have $30 billion worth of budget for sustainability or for a lot of their critical industries plan, right? Which means this is an extremely large number. And lastly, and this is something that you will see that I'll talk a lot about in the in this meetup today, that even when your servers are not doing anything at all, they're using 30 to 40% of your power, right? Which means that it's a lot of wasted energy in the place, right? So what's the solution? Any guesses? Anyone? Okay, very quiet people. Okay. Okay, what kind of solution do you have in mind? Okay, fantastic. Okay, great. And that's so fantastic, because I think even Nancy and somebody else also mentioned the first thing that you have to do is actually to monitor what's there. Without data, it feels like you're running like a headless chicken without knowing which direction to pursue, right? So energy monitoring and reporting. The second thing which you guys talked about is how can you actually do power down strategies? How can you load balancing? How can you do a lot of reduction in the number of servers for doing the exact same amount of work? Third is energy aware hardwares. And I think I'll talk a lot more about it when we reach there. And green data centers and energy efficient algorithms. We'll be looking at each one of them one by one, and a lot of it will be just scratching the surface, right? So while energy monitoring and reporting is extremely important, one of the most critical things that everybody has to understand is about how people imagine emissions in the world, right? So there is this committee called IPCC, which decides what should be the mental model of imagining what carbon emissions look like, right? So the way they define it, it's divided into three parts. One is called scope 1 emissions, scope 2 emissions, and scope 3 emissions, right? And it's very critical for you to understand this, because until you do not understand this, you don't know where can you or your company play that role, right? So scope 1 emissions are the emissions where you're directly contributing as an organization to the greenhouse gas emissions, right? So anything that you are doing because it's very critical to your own business, right? You're directly contributing. So for example, when I was at Blinkit, we were running a lot of these bikes because, you know, they were owned by our own organization. So any emissions from those bikes were actually scope 1 emissions for us, right? Scope 2 emissions, these are indirect greenhouse emissions, which are related to the electricity, heat, and cooling, right? So today when we are here, all this electricity that is being used is actually scope 2 emissions for VMware, because they're actually purchasing this electricity from somebody, right? And scope 3 emissions, which is like indirect greenhouse emissions, which are associated with the value chain, right? Now, value chain, what does it mean? It means that you're not looking at just what is being contributed in your cycle, but looking at the entire life cycle of something, right? So if I have to give you an example, when somebody brought that motorbike at Blinkit, were the products that were used to make that bike, were they contributing towards any greenhouse emissions? If yes, that comes in the scope 3 emissions for me. So a lot of companies are actually just trying to focus on scope 1 for now, but a lot of things that are relevant in the cloud ecosystem actually fall in scope 2 and scope 3 emissions, right? For example, when you're running private cloud, anything which is like, you know, energy related there, and anything where you're using electricity, where you're using AC systems, vents. I think somebody mentioned about data centers where they're actually using ways to cool it, right? A a lot of that comes under energy in scope 2 emissions, right? But a large part of all of this actually comes into scope 3 emissions, where what it means is, and I think I should define the word embodied first. Embodied emissions actually refer to the emissions that are happening throughout the life cycle of the product, where what we were talking about in the scope 3 emissions, right? Sorry. Okay. So, which means that any transportation. So, for example, if when employees are coming to, or today when all of you came to VMware, you contributed to embodied emissions for VMware, right? Which means that any travel that employees are doing when they're coming to their companies, that comes under embodied, right? So a lot of things like, okay, when people are transporting SSDs and stuff like that to data centers, that comes under embodied scope 3 emissions, right? Now, a lot of it might not be very clear right now, but what you need to know that if there is no absolute control, because these are indirect emissions, right? And as people who are running things on cloud, most of the things are on the scope 3 emissions. It is very important for all of you to look beyond what you're doing in your workplaces. You need to look at who are your service providers. Like as somebody was mentioning, that what is VMware doing? Is AWS doing the same if I'm using AWS? Is Google doing the same if I'm using them? So while when I talk to a lot of cloud engineers, most of them come and tell me that, yeah, if I just power down my services, most of them it will be fine. But the reality is that unless you do not know how your operator or how your service provider is actually doing things on their backend, you cannot really make a conscious decision. So a lot of things that we will be talking about here on and forward after the next topic will be a lot more to understand how things happen behind the scenes. Now, power down strategies, as you guys mentioned, a lot of things around auto scaling, idle resource detection, serverless computing, reserved instance, server consolidation, shutdowns and termination, containerization, which is actually critical for today's conversation, and a lot of load balances. These all are power down strategies. But one of the things that you should keep in mind is I did not use, why did I go with the word power here? It's because when you're talking about electricity and energy, power is what you pay for, right? So the first mental model that you need to imbibe for yourself is the moment I'm a cloud engineer and I'm using a lot of these strategies, I'm not only reducing the environmental impact, but I'm also reducing the cost. Because as I'm powering down a lot of things, I'm saving on a lot of cost for my service provider by reducing the electricity consumption that they are going to make, and also for myself because I'm using lesser and lesser resources. Now, I'm sure that a lot of these things you'll be discussing in the next set of conversations, so I decided that I'll probably focus on a lot of other topics. So, energy-aware hardware, right? These days, companies like Intel, Google, or NVIDIA, they develop specific architectures which are extremely low power in nature, which means that they have capabilities to figure out when the current is leaking and how can they actually go into sleep states when they're not being utilized, which is where we said that, okay, 10 to 20% or 30% servers are actually utilizing energy even when they're idle, right? So if we have hardware, energy-aware hardware, they can actually sleep down and the power utilization will actually be very, very low, right? A lot of other things, like, very similar concepts are also being implemented in spaces like memory and storage, where SSDs are actually extremely, extremely good for power minimization, which is why you must have noticed that a Mac actually runs for a really longer amount of time in terms of battery as compared to the other counterparts, because they use SSDs. And SSDs are extremely, extremely efficient in utilizing their power consumption, right? The next thing is a lot of energy-aware RAMs are also coming into the ecosystem, where people are able to figure out how can I prefetch this data in a more efficient manner. So it's not just about power, it's also about how can you reduce that constant moving of data here and there. What are RAMs all about? RAMs are all about moving data from here and there to ensure that you have the data that you want to use the most readily available, right? Which means that a lot of data is being transferred here and there, which uses a lot of CPU cycles, which means that you are going to be using a lot of energy to do this. So if you have more energy aware RAMs, you can actually do better prediction. You can also figure out a lot of patterns over time, right? And which is what a lot of these people do. Now, interestingly, these energy aware RAMs become like, why did they become famous was the question that I was asking while I was preparing for this talk, right? The reality is that when you're trying to constantly move data at such high frequency, especially in scenarios where you're using IoT devices, where you're using mobile phones or wearables like watches that are prominently used by all of us, right? Data is frequently erased and constantly being written, right? When that is happening, there's a lot of energy consumption that happens, right? And why does this happen? This happens due to a principle which is called Landauer's principle, which relates the thermodynamics principles and the information theory world, right? Which talks about what is the minimum amount of energy which we need to erase a data. Now, interestingly, today data is not flipped. When we say that things are moving between 0 and 1, it just represents that we are deleting or we're changing the voltage levels, right? And that there is some amount of energy that is associated with doing this operation. Now imagine if you're working on a data center scale, doing a lot of this means more and more and more energy consumption, right? Over time, people have figured out methodologies to actually do something which is called as reversible computing, where instead of using a lot of things in terms of voltage, they're using ideas from the quantum computing world and the magnetic world, where instead of erasing the data, you're just flipping the data values. And it is extremely low in terms of power consumption because flipping of those values needs much, much, much less energy. So these are extremely new technologies. Yes? Uh, I'm not sure. I'll have to read. Quite possible, but I'll have to look into data because I'm also not completely aware of how things happen behind the scenes in a much more deeper level. But I'll definitely read more and get to you about it. But theoretically, the way you're talking about it, it definitely makes sense, at least on some level. But sorry, I didn't know. And lastly, one of the most fundamental thoughts in the energy-aware hardware world is about dynamic voltage and frequency scaling. So one of the things, when we talk about anyone here who remembers the formula of power, that is equal to voltage into current, right? So if you reduce the voltage, you can actually reduce the power. You can actually, it will cost you less, right? And also, when you say current, the way current is kind of, a better representation for current is actually the frequency cycles that your CPU has to go through when they are processing an information, right? So if you reduce that clock cycle, it will give you a lot of great power management. But it should not come uh, at the at the risk of acceptable performance, because we are in a world where acceptable performance are actually somewhere in the range of milliseconds. And I don't think anybody here would like to see a phone which is extremely slow and gives you output in like 1 second or so, right? So you have to balance these things out. And that's what this dynamic voltage and frequency scaling algorithm actually does. It helps you figure out when to reduce something and when to go back to a level where performance is critical, right? It not only helps you with a lot of optimization on your like processing end, but it also improves the lifetime of the hardware and the battery, because it is able to because it is able to reduce the cycles that a battery has to go through. I know it might sound very, very like over the head right now, but this is something that you should definitely read more about, because it will give you mental models of how can you reduce a lot of things even in your daily life, because even in your daily life you're paying for electricity. It may be very, very cheap, but if you're thinking about grid scale, there are potential interesting implications. Now coming to the world of uh, data centers, right? And this is a very interesting quote that I found from Eric Schmidt. He says that what matters to Google designers is not speed, but power, and low power, because data centers consume electricity as much as a city. Now, to give you an example of the scale that they use, I think around 2010, when somebody was doing a study for Google, they realized that the same power that they use at their data centers can actually power a city which has the size of 2 lakh homes, right? Imagine the kind of energy that we're utilizing just in data centers, right? And not only this, there are enormous implications in terms of cost value. So Google was paying $10 billion per year in 2010-11 when they talked about this, right? So green data centers, and I think this is something which is very, very important for a lot of cloud engineers, because this is what will be more relevant for you going forward. There is a metric called power usage effectiveness, and it is one of the metrics that talks about how much a facility is actually utilizing in terms of power, right? How much is it getting versus how much it is utilizing. So if there is a PUE rating of 1.0, you're actually doing it extremely efficiently, which means that whatever power came, that actually got utilized. But the reality is not so perfect. The reality is that if most of the data centers operate at a number of 1.67, where if you give 1.67 watts of electricity, a lot of it is dissipated in terms of heat, and you're only able to use 1 watt, right? That's the number. And you know what the number for Google is? It's 1.10. They have done they've done extremely interesting stuff to keep it out. Another interesting thing that somebody from the Cube team was talking about is how do they cool their infrastructure, right? And it's an extremely interesting problem, especially when you're managing data centers. So there's a lot of cooling done via air, hot water, liquid cooling. Liquid may you can use stuff like oil, glycol, fluorocarbons like fluorinet, etc. Not only this, I don't know if you guys know, and if somebody uses AWS a lot, they would see that most of their servers are actually in Virginia region, right? There is a reason why it's in Virginia region, because it's relatively cold, and they could actually ship a lot of, so based on multiple factors, they realize that Virginia is cold enough for them to actually do a lot of things there with respect to data centers, right? So they use a lot of cool air from outside, and then they just pump it through, and then they don't have to use a lot of heat ventilation and cooling systems, which is called HVAC systems. So they are just utilizing the free air, which is even a lot of cost reduction, to be honest, right? And not only this, Microsoft recently came up with an idea where they're planning to put a lot of things under the sea, because when you're under the sea, there is constant circulation of water which is happening naturally, which means that you don't have to pay for the electricity that you're paying for in general in other areas, right? There are also things where you can, if you can adjust the speed of operation. So for example, anything to do with variable speed fans, anything to do with efficient lighting where lights only switch on when you are entering a particular room. I've noticed this on the outer ring road always, and it gives me a lot of headache every time I see that there are lots of companies which have their lights on all the time. Even if you are going through that space around 2 a.m. in the morning, it's always lights on. I'm sure that just by doing a small amount of thing, they can save a lot of bills that they are supposed to pay. Not only this, there are also interesting stuff around hot and cold aisle containment. So I think one of the interesting things that happens in a data center is that because you're running so many servers, the amount of heat that is getting dissipated is enormous, right? Enormous to an extent that most of the times the most efficient architectures are planned in a way that the cooling pipes are actually just beside a server, right? And I think somebody mentioned that they're sometimes also putting it just ahead of the servers as well, right? So that the efficiency of that cooling is extremely, extremely high, right? So these are a few of the ways that uh, greener data centers can actually really, really make an impact. Now, why should you know about green data centers is because when you are choosing a service provider, you should have the information about PUE value, and you should have the information about how are they doing it, right? And that can be a very good, important consideration for future. Like when somebody from VMware was talking about that, it made me aware that I don't only have options of AWS anymore. I can actually even go to something like VMware or something else which can provide me with all of this data, because this data is extremely critical for compliance for tomorrow. Moving on to but there is also hope, right, in terms of data centers. While there is so much, I think somebody in the VMware video also talked about how this data, we are just spending 2% of emissions today, but this number is going to grow a lot by tomorrow, right? But there's so many efficient technologies which are also available. So while the computing was increasing by 550% between 2010 to 2018, the energy consumed in Google's data centers only grew by 6%. They're actually one of the best in the industry that way. And coming on to the last topic, most of the people, when they think about energy, when they think about efficiency of an algorithm, they're most of the time thinking about time and space complexity. I think for a really long time, we have also stopped thinking about space complexity because space is so cheaper these days, right? So it's majorly time complexity. But a lot of people are now coming up with energy as a metric to also measure complexity. So you can imagine the algorithms of future will be not just evaluated against time and space, but also against energy consumption. And I think this becomes very apparent and true, at least in two areas that I can talk about. I have experienced it for myself, especially in machine learning and IoT. So machine learning, because your data, the data that you have to train and the resources that you need to train that data are extremely enormous and huge. The cost of electricity is extremely, extremely high, right? And now imagine you have to keep these machine learning models in your devices as small as your mobile phones, right? Mobile phones are extremely small space, extremely less, not just space, but performance efficient. They've become a lot better over time, but when you have to think about what kind of ML algorithms are going to power the future, they're extremely, extremely heavy in nature, right? So what can you do about it? So there are a lot of technologies that have been developed, which are very prominently known, but like you can also use them to think about energy efficiency, right? Transfer learning, where you're leveraging a lot of pre-trained data models, right? And they become a starting point for training new models. So which means that you have let go of such a large and enormous data. You have let go of such a large, enormous training time, right? So now what you do is you just take that and the transfer learning is done. Um, One of the things that I've always think people underestimate, but they should actually be thinking a lot more about is how can they compress their data? Because I think we are at a stage where compression algorithms are so great that they give you the same performance, the same output, but they're extremely energy efficient. So, and I have seen this myself when at one point of time we were paying something to AWS because they were billing something in terms of this much write units would cost you X amount. If you can reduce the units, you can actually save a lot of money. And just because we did data compression, we were able to reduce the cost significantly. So it's a very small thing, but very high impact. Lastly, online learning algorithms, because today the data that is being generated every day is humongous, right? So you have much, much more data every day to train on your algorithms. So it's very, very critical for everybody to know that there are ways in which you can take data incrementally and you can keep training your algorithms even in your real time. Not only this, looking at IoT, right? IoT is something which is like, I think most of the people don't realize it, but it's it's even going to be bigger than ML and AI, in my opinion, because a lot of things, even in the ML and AI space, are going to be powered through IoT. And that's because IoT, like, you need to ensure that you are not just, you don't just have efficiency in terms of like ensuring that the power is coming to you, the data is coming to you in the right format, but it is also extremely important that things are coming to you very, very fast. And a lot of efficiency in the IoT systems actually comes because they are actually so low power in nature. So there are so many low power protocols that I've interacted with. I've worked with MQTT, and it's so real time. So I remember when I was back in college, I was working on a project where we would take heat sensing data and we would tweet it. We would tweet anytime something is anomalous data, and it was really happening in a matter of like seconds, which is an extremely high efficient value, at least from my point of view. Also, anytime you can actually implement a low power sleep cycle in any of the things, always try doing that. That is one of the best things that you can do for your servers, for your resources, be it CPU, be it memory, etc., etc. Sleep, like putting things to sleep, actually makes them extremely energy efficient. So, and that's how you reach to a low power output. And lastly, there is an extremely interesting set of algorithms which are coming into picture, which are called adaptive sampling algorithms, where you look at how the data is growing, what kind of measurements you need to take, and based on that, decide at what frequency do I need to gather this data, rather than continuously streaming or continuously getting that data, right? So again, very similar to sleep mode, but a slight variation to it. And I think before I stop, I would want you all to take a minute and just think about, do you want to take, what do you want to take from this presentation? How can you actually imagine the world of cloud and sustainability to be beyond what you have been thinking about today? And thank you so much.
Thank you, Sancheeta. That's one of the best talks on sustainability that I've heard. And also made me realize all the bad code that I've written and how much carbon footprint that I've left behind.